Your engineering team just saved 200,000 euros by switching to open source tooling. 6 months later, your security review comes back with 3 untouched CVs, no audit trail, and nobody who can clearly answer who owns this. That saving is still on the slide. The liability is not. Today, I want to talk about open source from the perspective of someone who has deployed it in regulated environments. What cost conversation always misses, why the developer pool argument is real and underused, and one example where open source was the only path that actually worked. So the real cost equation. Every open source evaluation I have seen starts the same way. There are 0 license costs, the infrastructure costs are quantified, internal effort is usually underestimated, and the government's burden is not on the slide at all. Here's the shift that most teams do not internalize until it is too late. With a commercial SaaS product, the vendor owns the security posture, the patch cycle, the compliance documentation. You pay for that. It's baked into the contract. With open source, you take that responsibility, all of it. That is not an argument against open source. It is an argument for going in with a clear-eyed view of what you are signing up for. In a regulated environment, you need to know who is responsible for what version is running in your production. You need to be able to demonstrate that. An auditor doesn't care that the tool is popular. They care who approved that version and when was it last reviewed. The cost of open source is not the tooling. The cost is the governance discipline required to use it responsibly. If that discipline is already placed in your organization, open source is almost always the right call. If it's not, then you're saving money or you're deferring a risk event. The developer pool argument I mentioned earlier. So that's something I don't hear enough when it comes to enterprise technology decisions. And it's a strong case for open source on large and complex projects. When something breaks in a proprietary system, you're dependent on that vendor's support queue and that vendor's engineering capacity. When something breaks in a major open source project, you have access to a global community of developers who may already be working on the fix before you even know the problem existed. Let me make that concrete. Take a tool like Kafka, Kubernetes, or Postgres. These are not small community projects. They have thousands of active contributors, companies running them at a massive scale with real incentives to fix problems fast, and public issue tracker who you can watch the resolution happen in near real time. The mean time to resolution on a critical CV in a major open source project is often faster than the equivalent SLA from a mid-market commercial vendor. Not always, but often. For a CTO, this changes the risk calculation entirely. It's not, do I want a vendor support model or the community support model? The question is this project large enough, active enough, and mature enough that the community model is actually more resilient than what I would get from a single vendor? For mature, widely adopted open source projects, the answer is usually yes. The caveat, that advantage disappears if you're running a fork, a heavily customized version, or a project with low community activity. At that point, you're back to owning the problem yourself. Fine-tuning and capability gaps. Here is where open source moves from a cost story to a capability story. There are things you can do with open source that are simply not available in any commercial product. Not because the commercial product is worse, but because it is designed for a general use case, not your specific one. I want to give you a real example from a project I've worked on. We were running Airbyte as our data integration layer. It's open source and it has a large library of pre-built connectors, systems you can plug in and start moving data from A to B immediately. The hospitality system my client was using, well, we needed to integrate that, and it didn't have a connector. So we could have asked for someone to develop it, but well, it was easier to just do it ourselves. In a proprietary ETL tool, you have two options at that point. Wait for the vendor to prioritize your connector, which is unlikely if it's a very small niche product, or introduce a second tool into your stack to handle that specific integration. A second tool, of course, which means a second contractor, a second support relationship, second set of credentials to manage, etc., etc. So with Airbyte, the option was to build a custom connector. The connector development framework is documented, the interface is standardized, and we built what we needed, kept the entire data pipeline inside one tool, and did not introduce any new dependencies. This is not a cost story. This is a capability story. The hospitality system integration worked. It worked the way we needed it, and it stayed inside the governance boundary we had already established for Airbyte. You cannot buy that outcome from vendor. You can only build it. And open source gives you the framework to build it without starting from scratch. This is the fine-tuning argument as its core. Open source does not just give you access to a tool, it gives you access to the internals of that tool. You can extend it, adapt it, modify, fit to the constraints. Because your constraint is specific to your context. In regulated environments especially, that specificity matters. The data model, the audit requirement, the integration pattern, these are often not standard. Open source lets you meet them precisely. But then where does open source break down? So I want to be fair about the failure models, because they are real. Small community projects, as I mentioned before, with a small developer pool, I made in section 2 relies on these projects being large and active, as I said. If you are adopting a tool with 40 GitHub stars and 2 maintainers, you do not have a community. You have a dependency with no support structure. So you evaluate community health before you adopt. And the fork drift, which I also already mentioned. If you fork a project and diverge significantly from the upstream version, you lose access to the community patches, and every update becomes a manual merge. Also, there's an internal capacity gap. The governance and maintenance burden is real. If your team doesn't have the capacity to own it, then the theoretical advantage of open source does not materialize in practice. And there's the security at the edges. So open source code is public. That means vulnerabilities are also public before patches are available. For a brief window after a CVE is disclosed, a well-resourced attack knows exactly what to look for. Your patch cycle needs to be fast. None of these are reasons to avoid open source. They are reasons to go in with a plan. So here's where I personally land on this. Open source is not cheaper. It is differently expensive. It is not safer, it is differently risky. And for the right projects, with the right internal capacities, it offers capabilities that no commercial vendor can match, because the flexibility is built in by design. The mistake is treating it as a procurement decision. It is an engineering decision with governance implications. Make it accordingly. If you work in a regulated or enterprise environment and you're navigating AI and automation tooling decisions, this channel is for you. I cover the decisions that do not fit neatly into vendor demos. So subscribe if that's useful, and drop in the comment what's your experience been with open source and governance. Where has it worked and where has it broken? Thank you very much for watching, and I'll see you on the next one.